All right, so let's answer these questions here. What do you call an ionic compound with two elements? Okay, so we're talking about like we have two different elements, like sodium and chlorine together. We call that a binary ionic compound. And I'm going to abbreviate compound because I'm out of room. Okay, a binary ionic compound. What do you call an ionic compound with more than two elements? Okay, so let's look at something with more than two elements. Let's look at this. What if we had sodium chlorate? Here I've got 1, 2, 3 elements, and I'm going to call this a polyatomic compound. All right, so we're going to learn how to write formulas, and the process of writing chemical formulas requires the use of oxidation numbers. So we're going to use this periodic table of ion that has our oxidation numbers on there. So make sure you have this. We're going to need it. Okay, back at the beginning of our notes, these oxidation numbers tell us how many electrons an element needs to gain or lose to form a neutral compound. Okay? We have to form neutral compounds where the total charge of the ionic compound must equal 0. All right, so that's the whole purpose of writing these. We're going to practice using the swap and drop method. Okay, that's what I call it, the swap and drop. You'll hear me say this a lot. Okay, so when we go to write a formula, we're going to write the element symbols. Here we see barium, so we've got to go on our ion chart and find Mr. Barium. Here he is. He's in group 2, which is our alkaline earth metals, and it says his symbol is Ba with a 2 plus or plus 2. You'll see it written either way. And I'm going to write it here on this line. He's a plus 2. I know it says 2 plus. I just learned it this way, and I'm used to doing it this way. You do it however you want. Okay, and it says chlorine. Notice our ion chart says chloride. When chlorine becomes an ion, it becomes chloride. All right, so chlorine becomes chloride. All right, so we're going to put Cl with that element symbol there. Cl, and that is a -1. Okay, so the whole purpose of this is I need to write a compound that equals 0. So if I add these two together, I get a +1, right? So how do I cancel out a +2 with a -1? Well, I need 2 of these -1s to make that happen. So I'm going to write it over here. If I had, Ba plus 2, and chlorine, who's a -1, I would need 2 of these -1 chlorines to get back to 0, right? Because this is a +2, and then that would be -2. But instead of doing all of that, the easier way to learn how to write formulas is take the number, not the charge, the number, and swap it down below the other element. These are called subscripts. When they're written up here, that's superscript. And make these numbers the subscripts of your formula. So looking at this, it says my formula should have 1 barium and how many chlorine? 2 chlorine, BaCl2. All right, which is the same thing as this. I need 2 chlorine to cancel out this +2 barium. That's what we're doing. Swap the numbers, drop the signs. Let's look at another one. We have sodium. All right, and again, you're going to go to your ion chart and find Mr. Sodium. He's right here, number 11. He's got that little plus sign, means he's a +1. So I'm going to put his symbol with a +1. And then I've got bromine, and remember bromine when it is an ion becomes bromide. So he is a -1 because that little, oops, wrong one. That little minus sign means -1. Okay, what happens when I have a +1 and a -1 and I add that together? Well, that equals 0, right? So these just cancel each other out. So it is 1 sodium, 1 chlorine. I don't have to swap and drop. Same thing is if I had a +2 and a -2, okay? They would cancel each other out. Let's look at another example. Okay. I'm going to do one that has a +2 and a -2. You're going to practice these, or a +2 and a -2. Yes, that's what I said. Okay, so look here. We've got magnesium, who's a +2, and he's with oxygen, who's a -2. Those would just cancel each other out, and you'd get MgO, okay? So here's my example. I got the +2 magnesium, the -2 oxygen. Same thing. They're going to cancel each other out. MgO. Okay, but if they do not cancel each other out, like here, we've got this magnesium. Well, I guess I'll put it here. Magnesium is a +2. Iodine becomes iodide. That's a weird one. And he is a -1. What do I need to do with that? Again, I'm going to swap the numbers down to the other element and drop the sign. So it's MgI2. I need 2 -1s to cancel out this +2. All right, I want you to see if you can do D and E by yourself, and you can call me over to look at those if you want to. Let's look at some with some transition metals. We're going to do the same thing, but notice on these transition metals, there are Roman numerals. Where do those come from? Well, let's look at our ion chart. Look at all these with Roman numerals. See all these? That means there's more than one oxidation number, okay? Transition metals and then some of these other metals over here, they have them too. Tin, antimony, lead, bismuth, polonium. And then you'll see some down here, but we usually don't talk about these. Okay, you're going to do the same thing. This says I'm mercury 1. So I go find mercury. He's number 80. Where's Mr. Mercury? And it says mercury 1, not mercury 2, mercury 1. So I'm going to use the +1 mercury. But this one says we're going to use the +2 mercury. All right. We're still with oxygen, who's a -2. Okay, so when we go to write formulas with those, we're going to do the same thing. Here, we like these because those are easy. They cancel out. It's just HgO. But what happens here? The 2 goes here. The 1 goes here. Hg2O. All right, so see if you can do those. C, D, and E. Let's look at something that has polyatomic ions. Where are my polyatomic ions? Highlight that if you need to. Polyatomic ions, groups of elements that act like a single element. Okay, so this says I'm going to have Mr. Barium. We looked him up earlier. Remember, he was on this other page. Barium is a +2. And then you see this ATE ending, ITE ending. That's my indication that I'm going to find those up here. They're in alphabetical order, so I'm looking for sulfate. So I'm going to go to the S's. There he is, sulfate. This whole thing, you see that? SO4 with a 2-. This whole thing I'm going to put in parentheses. Keep it in parentheses. Outside is my charge. You cannot change anything inside the parentheses. Do not break up a happy family, okay? You'll be a homewrecker. So again, the same rules apply. A +2 and a -2 cancel each other out. So it's 1 barium for every 1 sulfate. When they don't match up, like here we've got magnesium. Magnesium, who's a +2, right? And he is with who? Nitrite. Notice it's an ITE. Here we go again. There's nitrate, nitrite. Nitrite is NO2. And again, put your polyatomics in parentheses with the charge outside. That negative sign means -1. Again, what am I going to do? Take the numbers, swap them to the other element, drop the signs, rewrite. I've got 1 magnesium, but I have 2 of these nitrites, 2 of them. I have to have parentheses, otherwise it looks like 22 oxygen. Okay, swap the numbers, drop the signs. On this one, ammonium, he's hiding from you. There he is. He's one of the only positive polyatomic ions. So he is NH4. Don't break it apart ever, ever. And that whole thing is a +1. All right. See if you can do those. And I will check them for you. Let me know if you have any other questions.